Dear students, welcome to Sia's digital classes. Today let us learn some problem based on F test. So how it goes on, how to identify the problem, let us learn here. So here is a question we have. A blood bank kept a record of rate of heartbeats of for several blood donors. So what they are doing, they are recording some heartbeat of the blood donors while donating the blood, how the heartbeat has been raised or how the heart functioning, they are checking and they are recording the data. So I and again in that recording they have checked for men and women separately and they have recorded that particular data. So check it out. First data is about a men's heartbeat, then next data is about women's heartbeat. So while donating the blood, how the heartbeat is raised or how the heartbeat is going on, they have recorded the data, and now they want to check the variation. So using appropriate test whether the variation among the men is significantly greater than the variation among women. So they want to check now the recorded values whatever we got, that variation, how the variation is going on between men and women, whether men heartbeat is more greater than the woman, they want to check it out. So variation is the clue for us. Variations we need to consider, that is population variances, that is your F test. So variation, through the word variation we have to we come to know that we can go for F test here. So population variances test for two population variances we do, right? So that is F test. So check it out the question properly whenever you are going to attempt. What is the given data, where are the clues we have, based on that only we'll decide which test we have to go on. So here there's a clue that variations we need to check for men and women, so we have to go for F test. So now extra information they have given here as tested 5% level of significance. Yes, LOS also they mentioned here. Assume suitable critical value for decision. Here it's a small sample test, they have to give the critical value also. They said to assume by our own, and let us check how everything goes on through the problem now. So here first we let us take a null hypothesis. Every time we'll do the test statistics, first step we'll write the null hypothesis, right? So here also null hypothesis I'm considering because those are about population variances. Our symbol goes as H naught is equal to sigma 1 is equal to sigma 2 square. Okay, so population variances we are comparing, so null hypothesis will be sigma 1 square is equal to sigma 2 square. So let us check the statement also now. There is no significance difference of variation of heartbeats of men and women blood donors. So here equal we are considering, right? So there is no variation, there is no difference, both are in equally, they have both men and women has equal heartbeats. That statement we have considered under null hypothesis. Now let us check it out for alternate hypothesis. So null hypothesis, after that alternate hypothesis, H1 is sigma 1 square is not equal to sigma 2 square, or actually it is greater than they have given, so it should be a greater than symbol here, not equal to. So I'll write here. So sigma 1 square is greater than sigma 2 square should be the symbol here, because in the question they are mentioned as greater than. So have a glance here, whenever in the question they'll give less than, greater than words, we have to take as it is for the alternate hypothesis, so that we can check which tail test it is. So here greater than symbol they have given here. So I have taken H1 as sigma 1 square greater than sigma 2 square. Now the variation of heartbeats of men blood donors is significantly greater than women blood donors. So that's what is in the question they want to check. Yes, greater than or not. Let us check it out whether it goes or not. Let us check it out through the test statistics, that is applying F test. So what is the F test formula? F is equal to S1 square by S2 square is a formula we have. If at all S1 square is greater than S1 square, S2 square, we'll utilize this formula. So here in F test, particularly after getting S1 square and S2 square, we need to check which is the highest value. That only should be in the numerator. So generalized formula I wrote here. Let us check it out based on the data. If S2 square is greater, let us shift the formula to numerator S1 S2 square and denominator S1 square. So generally F test formula will write based on the S1 square and S2 square answers. Whichever is the greater, that should be on the numerator. Okay. Now to get S1 square, S2 square, let us check it out the formulas also. First I require X bar, mean value I require. So X bar formula 1 by n1 summation x, because n1 into 2 samples we have. So 1 by n1 summation x, mean formula I wrote for x. And now let us check for y also. Mean for y bar is equal to 1 by n2 summation y. So x and y, two variables I am considering here. I have taken its mean. Now let us go for obtaining S1 square formula. So S1 square formula is the same what we have learned earlier, that is 1 by n1 minus 1 summation x minus x bar whole square. Similarly, S2 square formula also let us check, 1 by n2 square n2 minus 1 summation y minus y bar whole square. So these are the variance formulas we have. So for S1 and S2 we have considered. Now let us make the table so that we can get this x bar, y bar and S1 square, S2 square values. So given values I am writing here. First x values I have given, that is min values I am considering as x. So from the question, write down the values, all the values, whatever the min data we have. So I made a first column and I need its summation. I am considering it as some x. So I am taking its total now, summation x, add all the values, 60 plus 78 plus 84, like that. Add all the values up to 88. We got the answer as 603. So this is the total of x. Now I require x bar so that I can go for another S1 square formula. So first of all, let us do x bar. So x bar is equal to x summation x total we got as 603, and n is the sample size. N is equal to, count the data, how many numbers we have. So 1, 2, 3, 4, 5, 6, 7, 8. 8 sample size we have. So n becomes 8 for us. So n I have got, and summation x I have. So substitute here and get the answer for x bar, that is 75.37 I have got. Similarly, we have to do y bar also. But first of all, let us do this formulas. To get this formula, let us do this. As I have got x bar with me, so let us take this column, that is summation x minus x bar whole square. To obtain that, let us make the column here again. Let us go back to the table. So check it out. I need x minus x bar whole square, right? So that I wrote here as a second column. So what we have to do here, x minus x bar square whole square means take the x value, single x value, that is 60 we have. So I am writing here, check it out for that value. So 60 first value, consider for 60 x value minus x bar value. X bar just now we have obtained here, right? That is your 75.337. So substitute here 75.37 and it's a whole square we need to do. So do that value, we'll get this answer as 236.39. So this is how we'll obtain this column. Now let us check one more value also. So x value is 78 I have got. So 78 minus x bar value 75.37 I have. Whole squares we have to do. First subtract the values and do the whole squares. Then I have got this value as 6.89. Similarly, obtain all the values in this column using the x and x bar values, and then do the totals for that. That is 236.39 plus 6.89 plus 74.39 up to the 159.39. You have to add up all the values. So we got the total as 595.87. So one column I have got. I can get S1 square using this answer. Now let us check it out, the substitution for S1 square. So this summation x minus x bar whole square answer we got, right? So let us utilize that one here and let us get S1 square. This extra term 1 by n1 minus 1 we have to multiply for this summation. So what I am doing here is I am taking its total 595.87 divided by n1 minus 1, that is sample size 8 we have, 8 minus 1 you consider. So I got the answer as 85.125. So S1 square answer I have now. Now let us go for obtaining S2 square also. So here is the formula. So in this set I need summation y minus y bar whole square. So y bar already we have done and we got the answer as 74. Now let us go for the table and let us obtain this column also. So y values I wrote here, all the y values. Let us check it out, total of y. So simply add up all the y values, that is women data whatever we have, add it out. 68 plus 76 plus 71, so on up to 69 you add up, get the total 592. Now check it out, y bar, how we have obtained y bar. So y bar is equal to 592 by 8, we got as 74. Now utilizing this y bar value, let us obtain y minus y bar whole square. So y minus y bar whole square, nothing but take first value of y, that is 68 we have. 68 minus y bar value 74 we got. 68 minus 74 whole squares we need to do. So first subtract 68 minus 74, then do the whole square. I've got as 36. Similarly, go for all other values. 76 minus 74 whole square, like that you obtain all of the values up to the last value, we got as 25. Now add up all the column, entire column you add it, we'll get summation y minus y bar whole square. So that is your 148 I've got. Now let us utilize this value and get S1 square for us. So S1 square formula, we know this one I wrote here, 1 by n2 minus 1 summation y minus y bar whole square, right? So substitute it here, summation y minus y bar whole square we got as 148 divided by 8 minus 1 you do, you'll get the answer as 21.142. So we got S1 square, S2 square, both the answers are there with us. Now let us go for F value. To obtain F value, what I said, to obtain F value, first we need to check which is the highest value, S1 square or S2 square. So check it out, S1 square we got as 85.125 and S2 square we got as 21.142. So which is the highest value? Obviously S1 square value. So take the formula as it is, S1 square by S2 square, because S1 square is greater. So substitute the values, its totals you substituted, divided, get the answer as 4.02. Now I have got the F value, that is calculated value I have got. Now let us go for obtaining the critical value, then finally let us go for the conclusions. So decision, to take the decision we need the table value to compare it. So how we will consider the table value? F with n minus 1 comma n1 minus 1 comma n2 minus 1 degrees of freedom will consider, because it's a small sample test, definitely we required degrees of freedom, and the critical value, based on that we'll go for a table value, will obtain the F tables, from F tables will obtain the critical value. Here they did not mention any critical value, so we need to assume any value and we can go for the conclusion. So what I have done is I have taken from the F tables and I have sorted this table value. So from F tables I wrote here. In exam, if they don't provide for you, because F tables or chi-square tables they'll not provide in the exam, and if at all they say assume your own critical value, then you can take any of the critical value assumption and you can go for the decision. So here what I have done, because you will be revising all this, so from the tables I have got this table value. Now let us compare that with the calculated value and let us get the answers. So F calculated decision how we'll take, if F calculated is less than F critical, then we accept H naught, otherwise we reject H naught. So that is a decision always will make for the entire large and small samples, right? So let us check whether calculated value is less than critical value or not, so that we can accept the null hypothesis. But here what happened, 4.02 is a calculated value we got, and table value we have got as 0.99 only. So obviously our calculated value is greater than the critical value. So the 4.02 is greater than 0.99, which means we have to reject the null hypothesis. So therefore we reject null hypothesis, and obviously whenever we reject null hypothesis, alternate will be accepted. So and accept alternate hypothesis. So what is the conclusion now? Alternate hypothesis becomes a conclusion for us. So let us check it out. What is that? Therefore, the variations of heartbeats of men blood donors is significantly greater than women blood donors. So whenever they are donating blood, it seems men heartbeats is greater than the women. That's what the conclusion we made out of this problem. So this is the problem of F test. So hope you have understood entire concept. Nowadays they are asking a lot of problems in your exam. So do concentrate on the problem. In our book also we have many problems. So similar problems, you just practice it, go through it. How to identify the data is main here. So check it out each and every point in the question. What are the clues we have? How the data to be identified, and how that we have to implement in the particular test statistics. That all you do practice, then it will be easier for us to write your annuals. So I think you have understood through this problem how to handle the data and how to go for the F test. So this is the concept of F test, problem doing on F test. So I hope you have understood this session. See you all in the next session. Thank you.